Hi everyone, welcome to the channel. In this video, I would be going to discuss about chapter on real numbers. This is part 2, continuation. First part is over. This is second part. In this part, I will cover fundamental theorem of arithmetic, least common multiple and highest common factor, x raised to n ended with digit 0. So get started. First fundamental theorem of arithmetic. The statement of the theorem is every composite number can be factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors is occur. So statement says composite number can be factorized as a product of primes. So composite number is there and prime number. Prime numbers and composite number. Depending upon the number of factors, natural number can be divided into two categories, prime numbers and composite numbers. First, prime numbers. The natural numbers have only two factors. The factors are 1 and number itself. The least and only one even prime numbers is 2. 2, 3, 5, 7, 11, 30 are prime numbers. 2 only 2 factors 1 and 2. 3 only 2 factors 1 and 3. 5 only 2 factors 1 and 5. 7 only 2 factors 1 and 7. So the prime natural number have only 2 factors is prime number. The factors are 1 and number itself. The least prime number is 2 and 2 is the only one even prime number. Composite number. The natural number have at least 3 factors is composite number. 4 factors 1, 2, 4. 3 factors is there. 10 factors 1, 2, 5 and 10. 4 factors is there. Composite numbers have at least 3 factors. So the statement says every composite number can be factorized as a product of primes. Factorization is unique apart from the order in which prime factors occur. Explanation. Every composite number can be factorized as a product of primes. 10 is a composite number, factorized as a 2 into 5. 42 is the composite number, factorized as 2 into 3 into 7. This like every composite number can be factorized as a product of primes. 10 is composite number, 2 and 5 is prime. 42 is composite number, 2, 3, 7 is primes. Factorization is unique apart from the order in which prime factors occur. Unique means different order is possible, but prime factors are same and equal number of prime factor. 2 into 3 into C, 3 into 2 into 7. Order is different, but 2 is only one time in all the order. 3 is only one time all the order. 7 is only one time all the order. This is unique. This is factorization unique. Yes. Same prime factors and same number of times only occur in the products. Factorization. So this is the factorization is unique. Different order possible, but prime factors are same and equal number. So this is the fundamental theorem of arithmetic. Every composite number can be factorized as a product of primes. Factorization is unique means different order is possible, but prime numbers are same and it's come in same number of times. That is factorization is unique. Next, least common multiple and highest common factor. Least common multiple is multiple of 5. These are the multiple of 5, multiple of 7. Here 35 and 17 is the multiple of both 7 and 5. But least 35 is the common multiple of both 5 and 7. 17 also multiple of both 5 and 7. But least common multiple is 35. This is the least common multiple concept. 35 is the least common multiple of 5 and 7. This all the numbers are multiples of 5, but common multiple is 35 and 17, 70, but least common multiple is 35. 35 is the least common multiple of 5 and 7. Then highest common factor, factors of 42, 2, 3, 6, 7, 40, 21, 42, factors of 56, 2 and 7 is the factors of both 42 and 56. But 2 is least factor, but 7 is highest factor. factor. So highest common factor of 42 and 56 is 7. This is the concept of highest common factor concept. 2 is the common factor, 7 also common factor, but highest common factor is 7. So highest common factor of 42 and 56 is 7. So least common multiple and highest common factor in prime factorization method. First factorized as the product of primes. 6 is equals 2 into 3, 72 is equal to 2 cube 3 square, 120 is equal to 2 cube 3 into 5. This is called prime factorization method. First product of all the prime factors. Product of all the prime factors, 2 into 3 into 5. Prime factors with the highest exponent. 2 raised to 1 is there, 2 cube is there. So take 2 cube, highest product prime factors with the highest exponent. Take for the calculation of least common multiple, common prime factor with the highest exponent. 3 square, 3 raised to 1. 3 square is highest exponent. Then 5 only. So 2 cube 3 square into 5 is LCM. LCM is 360. First product of all the prime factors, then prime factors with the highest exponent. That is least common multiple is 360. For highest common factor, this is the factorization of primes, product of primes, then product of common prime factors, exclude non-common prime factor. Here 2 and 3 is common prime factors, 5 is non-common. So non-common factor excluded for the calculation of highest common factor. Product of common prime factors is 2 into 3. Prime factors with the least exponent. 2 cube is there, 2 raised to 1 is there. Take only 2 raised to 1. For the calculation of least common multiple, highest exponent. Highest common factor calculation, least exponent. 3 square is there, 3 raised to 1 is there. 1. For the calculation of least common multiple, product of all the prime factors, but highest common factor, product of common prime factors only. That is here product of all the prime factors, here product of common prime factors. Here highest exponent, here least exponent. HCF is 6. X raised end with the digit 0. Prime factors x have both 2 and 5 only. End with the digit 0. Exercise 1.1, question number 4. Check whether 6 raised to n can end with the digit 0 for any natural number n. Solution. Prime factors of 6 is 2 and 3 only. If 2 and 5 is there, then only end with the digit 0. But here prime factors 2 and 3 only. So since 6 raised to n never end with the digit 0. If prime factors of the base 2 and 5 only end with the digit 0, here 2 and 3 only, then 6 raised to n never end with the digit 0 here over the part 2. Thank you for watching.